Assalamualaikum and a very good day to everyone. We are from group AS1204M and today we would like to present our topic titled Nuclear Reaction in Star. This presentation is specially prepared for our respected lecturer, Sir Muhammad Shafi'i bin Mahmud, for the subject Physics 310. We hope this presentation will help everyone understand more about how nuclear reaction power the star and their role in the universe.
Here is my group member for this video presentation. First, let me introduce myself. My name is Raudatul Shakira binti Muhammad Sahabuddin and my student ID is 2023864658.
Hi, my name is Nur Amni Sami binti Arif and my student ID is 2023665024.
Hi, my name is Muhammad Akif Anaki bin Muhammad Farid and my student ID is 2023803902.
Assalamualaikum. My name is Muhammad Mustaqim bin Muhammad Sauli. My student ID is 2023617476.
Hi, my name is Muhammad Haziq Zikri bin Baharudin and my student ID is 202367738.
Here is a few outline of our presentation. First, we will start with the introduction of the topic. Next, the intellectual provocation in presenting modern physics, concept law and theory. Then we will move on the self-development for a career in modern physics. And lastly, we will end with the reference.
Okay, so in this slide, I will explain for you about the introduction of the topic that we have been selected for this video presentation. Okay, so first, the stars produce energy through the nuclear fusion reaction in their cores. Second, in stars like the sun, the proton-proton is the primary fusion process like the hydrogen to helium. And third, in larger stars, the carbon-nitrogen-oxygen cycle, and also known as CNO cycle, become dominant for hydrogen fusion. And lastly, nuclear reaction in star are fundamental to star life cycle, galactic evolution, and the existence of the life as we know it. So, the learning outcome that you will get is able to understand the life cycle of stars, including our sun. Here are the reasons why we choose this topic to our video presentation. So first, the nuclear reaction in the star are the fundamental to understand how the universe works. And second is connect to the physics concept like nuclear energy, fusion, quantum mechanics in a real world and also the cosmic setting. Third is explain how the stars shine, how they evolve, and how the element that make up our body and the planet were formed. And lastly is a fascinating topic that shows the power of nuclear fusion force beyond the Earth and happening naturally in stars. Here is our independent learning process that we have been used to complete this video presentation. First, we have referred to the Physics 310 lecture note that have been given by our lecturer. And second, we have made a group discussion to share and understand the ideas. And lastly, we use the trusted source such as NASA, article, and also the PBS Space-Time.
For this slide, these are challenges of nuclear reaction in star. First, extreme temperature and pressure requirement. Second, column barrier. Third, reaction rates are highly sensitive. This slide shows solution of challenges about nuclear reaction in star. First, extreme temperature and pressure requirement. The solution is scientists use hydrodynamic and quantum model to stimulate this condition in computer. Second, column barrier. The solution is in star, high thermal energy and quantum tunneling help nuclei overcome the barrier. Third, reaction rates are highly sensitive. The solution is use advanced computational models that factor in temperature-dependent cross-section. Next, I want to talk about the concept of nuclear fusion and its law of the concept, theory, and its importance. First, law of the concept. Law of conservation of mass energy. Some mass is converted into energy, which is E equal to mc squared during fusion. The theory is fusion occurs at extremely high temperature and pressure, where nuclei overcome repulsion and combine, as seen in star. And it's important, produce clean and powerful energy, no greenhouse gas, fuel is abundant, like hydrogen. Okay, facts of nuclear fusion in star. First, main energy source. Nuclear fusion is what powers star, including our sun. Second, require high temperature. Fusion in star occur at temperature over 10 million Celsius to overcome repulsion between nuclei. Third, hydrogen to helium. In most stars, hydrogen atom fuse to form helium through the proton or CNO cycle.
Nuclear fusion applicability in daily life. First, one of the most promising application is as a future energy source. Nuclear fusion is being developed as a clean, safe, and virtual limit from electricity. Unlike fossil fuels, it produces no greenhouse gases and doesn't leave behind long-life radioactive waste, making it an ideal solution for sustainable energy future. Second, fusion research has led to indirect medical advancement. For example, the study of plasma physics and the development of superconducting magnet, both driven by fusion research, are already being used in the technology like MRI machine and even in some cancer treatment method. Third, fusion also plays as a role in scientific research. Experiments in nuclear fusion have drive innovation in various fields such as material science, cryogenics, and vacuum technology. These advancements benefit many industries beyond just energy. Lastly, there's the potential for space propulsion in the future. Fusion energy could be used to power spacecraft, making space travel faster and more efficient. This could open new doors for long-distance space exploration.
Here is some recent advancement in the nuclear reaction in stars. The first one is the flaw in supernova models revealed. Using the meta-Oslo method, scientists at Michigan State University discovered that neutron capture rates on iron-59 are about twice as likely as previously thought. This calls for revision in stellar and supernova models affecting predictions of isotope production like iron-60. The second one is improved nuclear synthesis models. A study published in Astronomy and Astrophysics compared several nuclear mass models and found that the Weizsäcker-Sturm model best predicts heavy element abundance in metal-poor stars. This enhanced our understanding of the R process and stellar evolution. There are a lot of careers that is related to the nuclear reaction in star. For example, an astrophysicist. An astrophysicist studies the physical processes that occurs in star, focusing on phenomena like nuclear fusion and element formation. By analyzing starlight and radiation, astrophysicists uncover how stars evolve, how elements are formed, and how these processes shape the universe. The second one is a nuclear physicist. A nuclear physicist researches nuclear reaction both in laboratory settings and in astrophysical contexts, such as stimulating the extreme conditions found inside stars. They investigate how atomic nuclei behave during fusion or fission, helping to understand the processes that power stars and create elements in the universe. The third one is a research scientist in astrophysics or nuclear physics. They work in observatories, laboratories, or academic institutions to study stellar evolution, nucleosynthesis, and other cosmic phenomena. They analyze data from telescopes, run simulations, and conduct experiments to understand how stars change over time, how elements are formed through nuclear reactions, and how this process influences the structure of the universe. Last but not least, astronomer. An astronomer uses telescopes, satellites, and other advanced instruments to observe and analyze stars, supernovae, and fusion-related events in the universe. By studying the light and radiation emitted by these celestial objects, astronomers gather valuable data about nuclear fusion processes, the life cycle of stars, and the explosive events that spread elements across space.
Propose and plan specific skills needed to excel in the chosen career path. First, for the career path of an astrophysics, there are three core skill areas. Astrophysics knowledge. This includes understanding stellar structure, nucleosynthesis, star life cycle, and fusion process such as the proton chain and the CNO cycle. Physics master. Astrophysics need a deep understanding of classical mechanics, thermodynamics, electromagnetism, and especially quantum mechanics and nuclear physics. Advanced mathematics, strong skill in calculus, linear algebra, differential equation, and statistics are crucial for modeling stellar behavior equally. Second, let's talk about the nuclear physics career path. This role requires a strong understanding of nuclear physics, including concepts like fusion, fission, radioactive decay, and the structure of the nucleus. A solid foundation in quantum mechanics, particle physics, are also essential to understand the behavior of atomic nuclei. You also need advanced math skill, especially in calculus and different equations to model reaction. And finally, programming skill in language like Python, Fortran or C++ are important for running nuclear simulation and analyzing data. Lastly, the path of research scientists combines several technical ability. You need a strong scientific background of your chosen area, such as astrophysics or nuclear physics. A good grasp of research methodology is key. This includes designing experiments, testing hypotheses, and interpreting data. Skill in data analysis and programming are also essential. Tools like Python, MAT Lab are commonly used to handle large database. Lastly, familiarity with scientific instruments such as telescope, spectrometer, or particle detector is must depending on your specific field.
This slide explains why self-development is important, especially in the field of nuclear reaction in stars. First, understanding nuclear reaction needs deep knowledge of physics. We also need to keep up with current research to know how stars produce elements, make energy, and change over time. Second, it's important to learn and adapt to new technologies. In this field, scientists use advanced tools, so they must always improve their skill and learn how to use these tools more better. In short, to succeed in this field, we must always keep learning and improving ourselves. In this slide, we will talk about the challenge that students or individuals might face when pursuing a career in modern physics, and how this challenge can be overcome. The first challenge is abstract concepts and theories. Modern physics involves complex ideas like quantum theory, relativity, and electromagnetism. These are difficult for many students to understand because they are not something we experience directly in daily life. So, to overcome this, in some places like Dubai, physics tutor helps students by focusing more in real-world application and giving one-on-one teaching that fits each student's learning style. The second challenge is visually physical phenomena. Students often struggle to imagine concepts like gravity or electric fields. Without strong mental imagery, it becomes even harder to understand. So, to help with this, tutor may use picture, animation, and interactive tools to make abstract ideas more visual and easier to understand. So, overall, with the right strategies and teaching methods, this challenge can be managed effectively. That brings us to the end of our presentation. Thank you for taking the time to watch and listen. We hope you gained some new knowledge and insight about the nuclear reaction in stars. Once again, we are from Group AS1204M and we truly appreciate your attention and support. Thank you and have a good day.